Hello again. Hopefully you're doing well. NWA went well. Hopefully I'm still alive and I haven't been eaten by a bear. But no, in all seriousness, I hope you guys are doing okay and that things are working for you. Today we're going to talk about linear functions, which is muy importante in calculus. And we're going to talk about piecewise functions and boil it down to what you need to know for calculus. Okay. So if you'll remember, linear functions have the form this is slope intercept form. We will not use that very often. You can also be written as a function. You can write point slope form. So here's a point and the slope, of course. So that's point slope form. And then you can also do general form, which in our case would look like, well, let's just work it out. Everything goes on the left. So I have y minus 2/3 x minus 1 equals 0. These all have to be integers. All right, so I'm going to multiply by 3. 3y minus 2x minus 3 equals 0. That is general form. Okay. To graph these, again, start with the y-intercept or the point. Either one works. In this case, the y-intercept is 1. Then the slope is rise over run. You might also see it as the change in y over the change in x. You might also see it, we'll get to that here in a sec. So up 2 over 3, there's your line, okay? Let me point something out here. Those are the 2 points. Remember, you can label them as x and y coordinate number 1, x1, y1, and x2, y2 to calculate slope again. y2 minus y1 over x2 minus x1. So 3 minus negative 1 over 3 minus negative 3. This gives us 4 over 6, which is 2 over 3. Okay. In calculus, we write this as f of x2 minus f of x1 over x2 minus x1. I think I've already shown you that with rates of change. But basically, you're just this is a y value. You'd write this one as f of x2. This would be f of x1. They're just the y values. It's just a way to note it differently if you have f of x as your function. Okay. Remember, parallel lines have the same slope. Remember, and again, if you're not keeping up writing, just put your pencil down. This is all in paper for you on Google Classroom. Perpendicular lines, the slopes are negative reciprocals. All right, so this slope is 2/3. Remember, m means slope. Perpendicular slope would be the negative. And then the reciprocal, remember, that means to flip it. So negative 3 over 2. Okay. And those two lines, if I were to graph y equals negative 3 over 2x would be perpendicular. Okay. All right, so that's linear. Definitely have given you a sheet there with information on it. So you didn't have to write it down. I just wanted to run you through this with me telling you about it. This guy, if you see Taylor, he's from Utah. He's a very successful AP teacher. He wrote his own book. It's not published, but he gave all of us a copy that were at one of his trainings. So when I give you stuff that says Taylor, pay particular attention to it. Okay. All right. Piecewise functions. Just start the paper. And I know most of you are probably rolling your eyes right now because you don't like these. The nice thing about calculus, most of the time, somebody will say, here's a graph of a piecewise function. And they'll ask you information about it. Okay, so this is the nice thing about piecewise functions. You just have to interpret the graph. You don't actually have to graph it most of the time. Now, there have been instances where they've required it, so we are going to go over that. But when the time comes, you will see these. I will show you how to interpret them and use them. So I'm going to just show you today, remind you about how to graph piecewise functions. Okay, so if I have f of x, let's go with something with absolute value in it, because I'm feeling like absolute value today. Huh. Well, maybe not. Let's go with this. 3 if we're between 1 and 1 equals 4 if 1 to 4 that's my wife calling me, and x if. Okay. If you'll remember, 1 and 4 are kind of our walls. Okay. That's where we're going to split these. So this one here is only between -1 and 1. And this is the function. So between in here, f of x equals 3. Right, so that's just a constant. Solid dots because they're equal signs. Okay. About this one, this is just f of x equals 4. We have an open because it's not equal. 4 all the way across, solid dot because it's equal. And then the last one, f of x equals x. Now, normally we would draw that through here, right? Because there's no y-intercept, the slope is 1, but we can't do that. We have to start here. So we know that 4, 4 is a point on that line. It's an open dot. 5, 5, 6, 6, and then we're going to put an arrow because it does go on forever. All right. So that's one piecewise function. Let me actually add to that. Keep in mind, let's do an x is less than -1. I'll just do x squared. Okay. They can throw quadratics, absolute values at you. Okay. At x equals -1, -1 squared is 1. It's a hollow dot. At -2, it's 4. Okay, there's your piece. Normally, of course, it would come down here and go back up, but we don't want this piece in there. So there's a piecewise function for you. Remember, if I am asked for calculate f at 5, okay, the x value is 5, which is only in here, so I plug 5 in, and my output is 5. Okay. What about f of x? F of -3. Okay. -3 is only in here. -3 squared is 9. Okay. And then also, consider continuity. Okay. This function is continuous. Though this function is not continuous, okay, because there are breaks in the graph, right? So f of x is not continuous on the interval from -infinity to infinity. But f of x is continuous on the interval, let's say, from 1 to +infinity. Notice I'm not putting 1 closed, it's open, so we're not including 1 because there's an open circle, but 1 to infinity because that whole graph is continuous. Okay, so keep in mind we can restrict the domain and it becomes continuous. Okay, that will be important. I think that's it. You'll run into some quadratics and absolute values there. You're given a worksheet. It kind of looks like this. Get some practice, okay? The teacher should have the answers. Ask if you need help.